Okay, let's look at another one of these graph problems. It involves the second fundamental theorem of calculus. Um, you can see here that they've given you the graph of f is shown here. It's on a closed interval from 1 to 7, and h is defined as this integral from 1 to x. So they want us to find h of 1, so we plug in 1 here, and since this is what h is equal to, we don't really have to find the area under the curve, because whatever the value is, you subtract it from 1, and it's going to equal 0. Okay, moving on to part B. Well, before we move on, remember I replaced this for x, right? And since 1 was the bottom limit here, made it really easy. Okay, part B says the derivative of h at 4. So we have to take the derivative of both sides, right? If you take the derivative of this, you're thinking second fundamental theorem of calculus. And since that's just a variable 1x, you just replace it for here. So h of x, the derivative of that, is just equal to f of x. The derivative and the integral cancel out, basically. So what is this value at 4? Trace it over here, and it has a height of 2. So it's just equal to 2. Alright, on what interval is the graph of h concave up? So concave up means we need to take a look at the second derivative of h, and where it's greater than 0, it's concave up. Okay, so remember, this is f of x, but it also equals the derivative of h, right? So that's the graph that's shown. So the first derivative of that would equal the second derivative of h. So here, all these tangent lines are positive, right? Positive until we get here, where the tangent line is 0, and it becomes negative all the way until I get to where? Here, and then it turns positive here. So all we have to do is pick out these points between 1 and 3. So we say that it's concave up. X is greater than, actually, x is greater than 1 and less than 3. And it's also does the same thing between 6 and 7. Okay. So it's continuous on this closed interval here. Alright. Now on to part D. Find the value of x at which h has a minimum on the closed interval from 1 to 7. Okay? So we need to consider the endpoints, and the other endpoint would be 7. And then we also need to look at any relative minimums that we might have. So relative minimum, we're thinking we have to take the first derivative of h. Well, the first derivative of h, where does it equal 0? Well, it equals 0 here, and at the endpoint. So what is it, if we look at this number line, let's see if 5 is a relative minimum. We know it's a critical point because it equals 0. The derivative equals 0 here. So to the left of it, we have positive values, right? And to the right of it, it dips down here and becomes negative. So when you increase and decrease, it makes a shape like this. This is a relative max. Relative max, and we're looking for minimum in this problem. Let me double check that. Yes. So we don't even have to consider this value at 5. So what else do we need to do? We need to go look at the endpoints. So let's go back here and take a look at this. Oh, computer's not agreeing with me. I can try this another way. Huh. Seems to be frozen here. Let me try pausing this and fixing it. Okay, there we go. I hope that didn't freeze on you. Okay, so what is the function value here? Well, it looks like it's equal to 0 here, right? Because we found the endpoint already in part A. H of 1 is equal to 0. So we can go ahead and define that one. And let's see, what about H of 7? H of 7 is equal from 1, replace x with 7, and f of 2 dt. So basically all we have to do is find the area under the curve. Well, in this problem, we can't define these as line segments or anything like that, semicircles or trapezoids or anything. So we're going to notice that we'll call this region number, or letter A, and this is the area, region B. So from 0 to 5, or excuse me, from 1 to 5, we have a larger area. And the area for region B is going to be negative. And since the area for A is larger than the area for B, this is going to be a positive value. So I'm sure that's going to be enough justification to say that H of 1 is a relative, or excuse me, the absolute minimum. Okay. Well, I hope that's enough justification for them, and hopefully this video didn't pause too much in the middle.